My name is Dr. Danny Elvidge and I'm Senior Lecturer in Building Physics and Services here at UWE in Bristol, and I'm going to show you how to rearrange equations. Now this is something that worries a lot of people, but hopefully by the end of this video you'll realise it's much simpler than you think it is. So this video is split up into a number of sections. We're going to start by explaining why you need to know how to rearrange equations. Then we're going to talk about some of the cheats and tricks, and more importantly, why they don't always work. And then I'm going to give you the 2 rules of rearranging equations. And if you understand and follow these 2 rules, every time you try and rearrange an equation, you should be successful. So finally, when you've learnt those 2 rules, we're going to look at some examples. We're going to start off simple, and then they're going to get progressively more complicated. So if you're sitting there and you're thinking, why do I need to know how to rearrange equations? I'll just sort of show you this slide. This is taken from a group of my foundation year students, and I've asked them to rearrange the equation, or whether they're confident to rearrange the equation to find P. And you'll see that 45% of the students were certain they couldn't do it. In fact, only 23% of my students coming into the first year or level 0 know or are confident they know how to rearrange equations. So if you're sitting there and you don't know how to do it, you are not alone. Many people find this intimidating, but you really don't need to. So why should you know how to rearrange equations? Well, there are 3 really important reasons why it's useful to know. The first one is equations are much easier to handle before you put in the numbers. So let's just take an example of a calculation. If I'm doing the calculation 14.2356 squared plus 0.125 squared equals 14.236 squared. Anyone feel uncomfortable when I wrote that down? It's complicated. There's a lot of numbers to deal with in there. It is much simpler to write a squared plus b squared equals c squared. By removing the numbers, it makes us a lot more comfortable. The second reason it's really important to know how to rearrange equations is that if you know how to manipulate the equations, you only have to remember one equation that has all the variables in it. So this means you have to memorize a lot less. So I'll just show you what I mean by that. If, for instance, if we have an equation which is this, so that's an equation for calculating strength. So this section here is strength. This is load. This is span. Don't worry if you don't understand these, what I'm talking about here. This is just an example. This is the breadth. And this is depth. If you know how to manipulate that equation, you can work out the equations for load, for span, for depth, for breadth, as well as strength. So if you know how to rearrange formula, what this gives you is 5 equations in 1. You only need to memorize one thing, and if you know how to rearrange it, you have 5 equations you can use. The third reason it's very important to know how to rearrange equations is because manipulating equations can help you keep track of or figure out the units of a number. Because units are defined by the equations, if you manipulate or plug in numbers or cancel units, you end up with exactly the right units for a given variable. So bear in mind, in an exam, I might set a question which asks you to calculate, I don't know, the strength of a material. And I will give 1 mark for getting the right number, the right answer, and you'll get a 2nd mark for getting the right units. So it's much easier to figure out what those units are if you know how to rearrange the equation. For instance, let's take a quick example of a simple equation. If we have F equals MA. So what this means is force equals mass times acceleration. But don't worry about that at the moment. In an exam, I'd be able to say, okay, well, what is the units for force? Well, I know that the units for mass are kilograms, and I know that the units for acceleration is meters per second minus 1. Don't worry about that minus 1 at the moment. So it means that force equals kilograms per meter second minus 1, which is, some of you will know, that's otherwise known as a Newton. But by knowing exactly what units are used in different parts of the equation, when you rearrange it, you will always get your units right at the end. So those are the 3 reasons why you should know how to rearrange equations. Let's have a little look at an example. How would you arrange this formula? So I'm looking for you to rearrange F equals ma. Right, there are 3 ways to do this. The first way is a method called the triangle method, and it's used a lot in secondary schools, in physics and some areas of science, and it's a quick way for rearranging equations which use 3 variables. Some of you may know this. So what you do is you draw a triangle. In that you place the 3 variables. So these are next to each other, m and a, so I'm going to put them next to each other in my triangle. And f, I have to go at the top, it's the only space left. So I know, first of all, that f equals ma, because that's how I built my triangle. But now, by looking at the triangle, I can derive a few other equations. For instance, if I want to find a, I can look at the triangle and say, okay, I need a equals, well, it's f over m. F over m. And if I want to work out m, I do exactly the same. I look at my triangle and I go, well, m equals, it's f over a. So that's one way of rearranging equations, which is taught in secondary school, and it's called the triangle method. And it's often useful for checking other calculations. And then there's the second method, which is often taught. Now this is often called the move and flip method. So the move and flip method would say that, okay, I know f equals ma. We're using the same equation again. But when we put m and a next to each other, we know that we're always saying there's a time size there. And the move and flip method says that whenever you drag a part of an equation over this equal sign, you're going to change the function, whether it's times, divide, to its opposite. So the move and flip would be able to say, I'm going to take that piece there, times a, and I'm going to drag it past the equal sign. And I know that when I go past the equal sign, the times is going to flip and become its opposite, the divide. So what that means is we should be able to write this instead. M is on its own, but now it's turned into a divide a. So f divided by a. So those are the 2 methods you can use, a triangle method and a move and flip method. But both of these methods are essentially useful cheats. Now they're useful, but they're still cheats, and they're not going to help you all the time. For instance, we looked at a simple equation. What if you now had to rearrange this equation? Could you still use the triangle or the drag and drop method? They won't work anymore, which means you really do need to know you can't use these useful cheats all the time. You need to learn the third method the right way to rearrange equations. And that's what we're going to look at next. So you can't always use the cheats and tricks to rearrange equations. We're going to have to learn to do it the proper way. Now, whenever I do this in my lectures, I always get the students to think of one happy thing that's happened to them today. The idea is if you go into this and you feel nervous or worried that you won't be able to do it, you're already what I call pre-failing yourselves, and this is going to be a lot simpler than you think it's going to be. So I want you to take a moment, you can pause the video if you wish, just think of one happy thing that's happened to you today so that you go into this with an open state of mind. So there are two rules to rearranging any equation. If you keep these two rules in mind, you'll get it right every time. And I'm going to give you the long version of those rules, and then each time I rearrange equations, I'm going to write out a shortened, simplified version. So the first rule is, you can add, subtract, multiply and divide by anything, as long as you do the same thing to both sides of the equal sign. So in an equation sign, the equal sign acts like a fulcrum in the balance. If you add 5 to something on one side of the balance, you have to add the same to the other side to keep that balance steady. The same thing goes for an equation. Doing the same operation on both sides means the equation is balanced. You want to keep it from changing. So that's rule 1. Rule 2 is to move or cancel a quantity or variable on one side of the equation, you perform the opposite operation on both sides of the equation. Now that may be making people a little worried. The language there is a little complicated, and that's why we've got the examples. You'll soon see why those rules matter, and you'll understand them better as we go through the examples. The key to this is, if you stick to these rules, you shouldn't have a problem. And it's practice, practice, practice. The more you do this, the more comfortable you're going to become. Everyone has to do it for the first time. Everyone, including myself, gets worried when they start doing these maths. If you keep practicing, you'll become more confident. So let's have a little look through some examples, and let's try and keep those happy thoughts in your head. So before I do any of these equations, I'm going to write out my two rules. Rule 1. Do the same thing to both sides of the equal sign. And rule 2, to cancel something, so to get rid of it, say, you must do the opposite. So plus becomes a minus, a times becomes a divide, a square root becomes a squared. And if you follow those two rules, all of the equations you rearrange should make sense. So we'll give an example. Now we're going to start off quite simply, and then we're going to get more complicated. So to start off, we're going to look at force equals mass times acceleration. That same equation we looked at earlier with the cheats. Now let's work out how you do it properly this time around. So we know that when we write it like that, we're actually saying force, mass acceleration. We're saying it's mass times acceleration. So you can write this in a number of ways. For instance, force equals mass times acceleration is the same as force equals acceleration times mass. All I can do is I've swapped those around, and that's fine to do. For instance, I can swap these numbers around because you know that 5 times 2 equals 10. You also know that 2 times 5 equals 10. It doesn't matter which way round these two symbols go. They are both coming out with the same answer. So that explains just quickly why I can swap that round. Now I've got times mass, and I want to get A on its own. I want to find what A is. So what I can do is follow the two rules. I'm going to do the same thing on both sides of the equation, in the equal sign, and to cancel something out, I'm going to do the opposite. So to cancel out this m and move it on its own, I can divide by m. And I'm going to do that on both sides of the equation. So I'm going to have f divided by m, and I'm going to have a times m divided by m. Now, there's no point timesing something by m and then dividing it by m at the same time. These two cancel each other out. So I can cross that out, and I can cross that out. Which what it leaves me with is f divided by m equals a. Or to write it in another way, a equals f divided by m. And you can use the cheat method to show that that is correct. So let's just talk that through again quickly. We have two rules: do the same things on both sides of the equations, and to cancel something out you must do the opposite. And that's what I followed through here. So we started out with f equals ma, which we know means f times a. We can change these around. If we want to find a on its own, we don't have to keep it on the end. We can move it to the beginning, because we know that a times m is going to be the same as m times a, in the same way that 5 times 2 equals 10 and 2 times 5 equals 10. So to get rid of this times m, we can divide it by m, do the opposite, and we've got to do that on both sides of the equation, as the rules say. So we divide one side by m and we divide the other side by m. But then we realise there's no point having something times m and then dividing by m. They cancel each other out, so we can remove them. And what we're left with is f divided by m equals a, which is the same as a equals f over m. That's the equation rearranged in the correct way. Now there may be some of you looking at this saying, yes, but the triangle way was quicker. But when it gets more complicated, we've already shown the triangle way doesn't work. So I'm going to show you another example with a slightly more complicated way of doing it. So, now, let's make it more complex. Now I'm going to stick to the same rules because the same two rules apply. Rule 1, do the same thing on both sides of the equal sign. And rule 2, to cancel something out, you must do the opposite. So just to clarify, what I mean is the plus sign becomes a minus, the times sign becomes divide, and a square root, becomes square, like that. So let's look at a more complicated equation. This time we're going to have y equals mx plus b. I'm just going to take a moment to explain why I've drawn my x in that way. Because some people will be thinking, why have I drawn it like that, as two curves? This comes up quite regularly. And just to explain, it's because if I'd used that symbol, that means multiply. So that's why in an equation when we say x, we always use that symbol rather than a simple multiple symbol, just to let you know. So in this case, I'm going to ask you to find b. We're going to find that one there. So to start off with, I'm going to write out my equation in a different way. I'm going to start by saying y equals b plus mx. So remember, it doesn't matter that this is moved around. Because we know, for instance, 3 plus 5 equals 8. And 5 plus 3 equals 8. It doesn't matter if that's b plus mx or mx plus b. They are the same answer. So all I've done is I've changed the way that part of the equation is arranged to make it easier for me to manipulate the equation. So I've got plus mx and I want to get b on its own. So I can do the opposite. I can say minus mx. And I'm going to do that to both sides of the equation. So I'm going to have y minus mx equals b plus mx minus mx. Now again, you should see that there's no point adding mx to b if you're only going to take it away again. So you can cross that all the way through. It doesn't matter. It's being cancelled out. That means that what I have left on the equal size is y minus mx equals b. Or to write that in another way, b equals y minus mx. You've rearranged the equation above to find b. And you've done that by using the two simple rules at the top. So, can we go more complex again? Well, yes, we can. We just need to stick to the same two rules. And I'm going to write these rules out each time because this is the thing you really need to remember. If you get these rules, everything will work out. So, rule number 1 is do the same thing on both sides of the equal sign. And rule number 2 is to cancel something you must do the opposite. So once again, plus becomes minus, times becomes divide, and square root becomes squared. If you keep those two rules in your head, you should be able to do more and more complicated equations. So let's try this one. A squared plus b squared equals k squared. Once again, it doesn't matter that that's A, it doesn't matter that's B, it doesn't matter that's K. That could be fish times cup of coffee times crayon. And we could rearrange the equation in just the same way. It doesn't matter what these letters are, they're just in place of a number to keep it nice and simple. And this time we're going to say, let's find A. That one. So we need to get A on its own. So let's draw out our equation once again. It's A squared plus B squared equals K squared, and we need to get A on its own. Well, A at the moment is A plus B, so we need to get rid of that plus B. So how do we do it? Well, we do the opposite. So I'm going to say minus B, and I'm going to minus B on both sides of that equal sign, just following those two rules. So this time I have A squared plus B squared minus B squared equals K squared minus B squared. But we've already said there's no point adding something, only to remove it, so we can take that out. And that will give us A squared equals, I'm going to move the equal sign over a bit, equals K squared plus, minus B squared. But we're trying to find A on its own, and at the moment we've got A squared. So how do we get rid of that A squared? Well, we can follow that by rule 2, because we know the opposite to squared is a square root. So I can say I'm going to square root both sides. So this time it becomes the square root of a squared equals the square root of k squared minus b squared. But as we've already said, there is no point having a squaring, using a square root on a square. They cancel each other out, so I can cross that out and I can cross that out, which means we have a new equation of a equals the square root of k squared minus b squared. That is your equation rearranged to find a. And can you see that we're using exactly the two same rules as we always did? They haven't got any more complicated, and yet the equations we are now resolving, we are rearranging, are much more complicated. The two rules stay simple, no matter how complicated the equation gets. So let's do one more. Let's make it really complicated. So, can we do something really complicated? Well, yes, we can, because we're still following the same two simple rules. And I'm going to write them out again, because if we keep writing these things out and you keep them in your mind, you should be able to tackle any equation, no matter how complicated it looks. So what are those two rules again? So we have rule 1. You do the same thing to both sides of the equal sign. That keeps everything balanced. And rule 2 is to cancel something out So to get rid of something, you must do the opposite. So, for instance, plus becomes minus, times becomes divide, and the same thing goes for the square roots becoming squared. So let's do something that looks really very complicated. Here's the equation we're going to deal with. There. Now that's a doozy of an equation. I wouldn't be surprised if some people are looking at that at the moment thinking, that's impossible, I'll never be able to do it. But don't worry, if you stick to those same rules, no matter how complicated the equation gets, you should be able to rearrange it. Just to illustrate, we are going to find in this equation this section here. Now, first of all, what does that mean? It doesn't matter. Who cares what it means? Remember, we are just replacing numbers with symbols to make it easier on ourselves. Now, in reality, this means a radiant temperature. It's an equation we do for calculating thermal comfort, but it doesn't matter. It could be a picture of a coffee cup or a orange. It really doesn't matter. We are going to find it what it is. So I'm just going to call these symbols thingy G and thingy R because I don't want you to get bogged down in what these actually relate to. But we are going to find thingy R. So how do we do that? Well, first of all, let's put in an equal sign. We know that we've got to do the same thing on both sides of that equal sign. And we know that if we're doing one thing on one side, it's going to be the opposite on the other. Those are our two rules. So we're going to start thinking, how do I get thingy R on its own? Well, one of the first things we can do is you've got this huge section, this whole bottom section. If we got rid of that that would mean we've only got the thingy r with the top bit. So what we can say is, okay, it's divide by that whole bottom section. I'm going to take the whole thing and I'm going to times it by that bottom section. And I'm going to put it in brackets so that I know I've got that whole bottom bit. So I'm going to say times 1 plus 2.35 the square root of VA. And I'm going to do that on both sides of the equation. So I'm going to draw it out here longhand, if that's all right. What I now have is thingy G times, and that whole bracket, 1 plus 2.35 square root of VA, and that equals, sorry, there's the rest of the brackets, and I'm going to write out the whole side of the equation, because I'm going to do it by stage, even the cancelling out part, because the simpler I keep it, the easier it's going to be for me to keep track of what looks like quite a complicated piece of maths. So I'm still going to have thingy r, which what we're looking for, plus 2.35 thingy a VA. And that's being divided by 1 plus 2.35 square root of VA, exactly as we've done over here. If you'd like, you can put a bracket around it. If you want to match those two, it doesn't really matter. But what I've got to do, remember, is I'm doing the same thing to both sides. So if I've times one side by that, I've got to times the other side by it too. 1 plus 2.35 square root VA. Now, what you should be seeing here is there's no point dividing this by that and then timesing it by again. The two cancel each other out. So I should be able to cross all of that out. So now let's take a moment to draw what we have left over. Putting in my equal sign, we now have the thingy G measurement times 1 plus 2.35 square root VA. And now we've only, because these two pieces are cancelled out, we've only got thingy r plus 2.35 a. So look, we're on our way. We're on our way to finding that. What we've got to do now is get rid of the rest of this. So we can do exactly the same as we did a moment ago. We're going to take this whole section and move it on the other side. And we're going to do that by doing the opposite of that plus. This time we are going to minus, and I'm going to put brackets in again, because I'm taking the whole section over, 2.35 a square root VA. Okay? So that's what I'm doing on both sides of the equation. I'm going to take a moment to write that out in full. So that means I now have this part of the equation again, plus 2.35 VA, close it, minus 2.35 VA equals QR on its own, because I've taken that whole section out. That's cancelled out. In fact, let's write it out in full. 2.35 a VA, and because we're doing both sides of the equation, minus 2.35, just to show you, sorry, going a little bit off the page, but that doesn't matter, because if I'm adding that and then minusing it away, we can remove both halves of that. So now to rearrange just this section that's left over, you end up with R equals thingy G times plus 2.35 square root of VA minus 2.35 thingy A VA. Closed it. So that was a lot of maths. But what we've ended up with is this equation here. That's rearranged. If you look at that sheet now and you hadn't seen the process and you didn't know those rules, you'd think that that was incredibly complicated maths. But really, we've only done two really simple things. We've done the same thing to both sides of the equal sign, and to cancel something out, we've done the opposite. So now we've worked through some really complicated maths using those same two simple rules. No matter how complex your maths, if you stick to the two rules, everything should work out fine. Now, I've put on the slide opposite a more complicated version, the way we originally explained, but if you want to keep the simple way in your head, this is it. This is how I've tackled every one of those equations from f equals to ma to that horrifically complicated last equation. Rule 1. Do the same thing to both sides of the equal sign. So remember, it's like a seesaw. If you do to one thing, you must do it on the other. And if you keep following that through and you write it out longhand, that's particularly useful. If you write it out long length, you'll see the bits you can cancel out. Don't try and skip a stage. And rule 2, to cancel something, so to get rid of it, say, you must do the opposite. So a plus becomes a minus, a times becomes a divide, a square root becomes a squared. And if you follow those two rules, all of the equations you rearrange should make sense. Now, we don't only just do these videos at UE, we also have Espresso Math services, we have staff members on hand to help you through these things. So this isn't the only avenue within UE to help you with your maths. So when you arrive here, when you're working here, you will always have the support of staff to help you through things that you don't get.